Chasing light, a real-time journey across the universe. Have you ever wondered what it would feel like to travel at the speed of light? To move so fast that the universe itself seems to shrink before your eyes? The speed of light is not just a number, it is the very fabric of reality's limits, the ultimate benchmark of motion in the cosmos. At 299,792,458 meters per second, light defines how we perceive space and time. This speed is so fast that it's almost incomprehensible, so fast that in one single second, a beam of light could circle the Earth more than 7 times. And yet, when measured against the vastness of the universe, even light feels painfully slow. Tonight, we are going to do something extraordinary. We are going to take a journey through space as if we were riding on a single photon, an invisible traveler moving at the fastest speed allowed by the laws of physics. You will see the universe in real time at light speed. And what you discover will change your understanding of both speed and distance forever. The first step, Earth to the Moon. We start our journey standing on the surface of the Earth. As our photon is released, we shoot upward at nearly 300,000 kilometers per second. The buildings, mountains, and clouds blur beneath us and vanish in less than a blink. In just 1 second, we've already left the Earth's atmosphere and raced past hundreds of satellites orbiting our planet. In 1.3 seconds, we reach the Moon, 384,000 kilometers away. Think about that. All the rocket launches and Apollo missions that took days to reach the Moon, we have already completed in less than 2 heartbeats. If someone on Earth were to shine a flashlight at a mirror on the Moon, the round trip for that beam of light would take just 2.6 seconds. The Moon now fades behind us, growing smaller and smaller as we accelerate toward our star, the Sun. The journey to the Sun, for most of human history, the distance to the Sun seemed almost infinite. Even light takes time to cross the 150 million kilometers between us and the Sun. Exactly 8 minutes and 20 seconds after leaving Earth, we arrive. During those 8 minutes, here's what happens back on Earth. The International Space Station orbits the planet nearly once. Millions of people blink, not realizing that the sunlight warming their faces left the Sun 8 minutes ago. If the Sun were to vanish right now, Earth would remain lit for those final 8 minutes before falling into total darkness. The Sun, glowing with unimaginable energy, is not just our star, it is a time machine. Every photon of sunlight you see today is 8 minutes old. But our journey is far from over. We are going to leave the warmth of the Sun and push beyond the planets. Racing across the solar system, passing Mercury and Venus takes just a matter of seconds. Then, after 3 minutes, we speed past Mars. For spacecraft, like NASA's Perseverance rover, the trip from Earth to Mars takes around 7 months. At light speed, we covered it in less time than a single pop song. Continuing outward, the asteroid belt flashes by. The massive gas giants, Jupiter and Saturn, approach rapidly. By the time 43 minutes have passed, we reach Jupiter, over 778 million kilometers away. This means that when we look at Jupiter through a telescope, we are seeing it as it was 43 minutes ago, not as it is right now. Another 35 minutes later, we pass Saturn, its breathtaking rings glowing faintly. We continue racing outward. After 2 hours and 40 minutes, Uranus is behind us. After 4 hours, we pass Neptune, the edge of the known planets. In just half a day, 17 hours, we finally cross the outer boundary of our solar system, known as the heliopause. This is where the solar wind from the Sun gives way to the interstellar medium, the space between stars. From here, the sun is just a bright star behind us. The vastness of interstellar space. Beyond our solar system, the true emptiness of space begins. The distances here are so vast that even light seems slow. Our nearest neighbor, Proxima Centauri, lies 4.24 light-years away. This means it would take over 4 years of non-stop travel at light speed just to arrive there. Let's pause to truly appreciate this. In 4 years, you could finish an entire college degree. In 4 years, Earth would complete 4 full orbits around the Sun. And yet, a single beam of light, moving at the universe's top speed, would only just be reaching the next star. This is why interstellar travel is such a monumental challenge. Even our fastest spacecraft, like Voyager 1, which has been traveling for over 45 years, has not yet left our solar system's neighborhood in any meaningful sense. At its current speed, Voyager 1 would take more than 70,000 years to reach Proxima Centauri. But we, riding our photon, will arrive there in just 4 years. Crossing the Milky Way. Once we reach Proxima Centauri, we've only taken the tiniest first step into our galaxy. The Milky Way is 100,000 light-years across. At light speed, crossing it would still take 100,000 years. Imagine this. When humans first began making stone tools around 2.5 million years ago, if a beam of light had started traveling across our galaxy, it would still not have reached the other side today. As we race toward the center of the Milky Way, we pass countless stars, billions of them, each with their own planets, moons, and perhaps even life. Every one of these stars is separated by light years of empty space. Even at the speed of light, the journey across just a single small section of the galaxy can take hundreds or thousands of years. Beyond our galaxy, but our galaxy is just one of trillions. The nearest major galaxy to us, Andromeda, lies 2.5 million light-years away. Even at light speed, this journey would take 2.5 million years. To put this in perspective, the light we see from Andromeda tonight began its journey when our ancestors were still learning to control fire. The image we see in the night sky is a fossil of the past, a record of how Andromeda looked 2.5 million years ago. The edge of the observable universe. As we continue racing outward, the distances grow beyond imagination. The observable universe stretches 46 billion light-years in every direction. This is the distance that light has had time to travel since the universe began, 13.8 billion years ago. Beyond this horizon, we cannot see anything, not because nothing is there, but because light has simply not had enough time to reach us. The farthest light we can detect is the cosmic microwave background, the faint afterglow of the Big Bang itself. This light has been traveling for nearly 13.8 billion years, carrying with it the story of our universe's birth. The time-bending nature of light now. Here's something truly mind-bending. From the perspective of a photon, the concept of time doesn't exist. At the speed of light, time effectively stops. This means that for the photon we are riding, the journey from one end of the universe to the other happens instantly. But for us, stuck in the slow flow of time, the same journey takes billions of years. This strange connection between time, space, and speed is at the heart of Einstein's theory of relativity. Light in our daily lives. It's easy to think of light as something abstract, something belonging to stars and galaxies, but its speed affects everything we do. Every phone call, video chat, or internet connection relies on pulses of light traveling through fiber optic cables. When you talk to someone on another continent, your voice is converted into light signals that race beneath the oceans at nearly the speed of light. Even then, a slight delay exists, a tiny reminder of the finite speed of light. What if we could go faster? Could we ever travel faster than light? According to physics as we know it, the answer is no. The speed of light is the ultimate cosmic speed limit. As any object with mass accelerates toward light speed, its energy requirement skyrockets, approaching infinity. This is why no spaceship, no matter how advanced, can ever reach or surpass light speed using conventional means. Science fiction often explores ideas like warp drives or wormholes, where space itself is bent or folded to allow faster-than-light travel. While fascinating, these remain purely theoretical. For now, light speed isn't just the fastest we know, it's the fastest there is. A universe. By light is not just speed, it's our window to the universe. When you look up at the stars, you are seeing light that has been on a journey for years, centuries, or even millennia. The starlight you see tonight might have left its home long before the pyramids of Egypt were built. When astronomers peer through the James Webb Space Telescope, they are looking billions of years into the past. The galaxies Webb reveals are so distant that their light began its journey when the universe was still young, when the first stars were forming. Returning home. As our journey comes to an end, we leave the edges of the universe and race back toward our tiny blue planet. In less than 17 hours, we cross the solar system. In 8 minutes, we pass the sun. In just over 1 second, we're back at the moon. And in an instant, we land on Earth. We started with a simple question: what does light speed mean? The answer is more profound than we might think. It's not just a measure of speed, it's a cosmic storyteller, carrying the history of stars, galaxies, and the universe itself. Final words. The speed of light shows us both the greatness of the universe and our smallness within it. It reminds us that we are connected to everything through the light we see, whether from a nearby star or a galaxy billions of light years away. Every time you look at the night sky, remember that you are seeing history written in light. The universe is speaking to you across the cosmic ocean at 299,792 kilometers per second. Thanks for watching.